Hello everyone, my name is Chris Hickson. This lesson is for 4th and 6th period. In this class, classes will take place on the week of Monday, January 23rd. This week we'll be taking our first exam. So on Monday, we're going to be focusing on the study guide. This lesson I have prepared here is going to go over the study guide. The exam we will take on Wednesday, and then on Thursday, we're going to begin a new topic. So in this video, I'm not going to talk about that. This video is going to be focused on primarily the study guide, and I'll have a video next week for our new topic. Alrighty, so number 1 says, what is the difference between a rate and a unit rate? Well, you'll recall from our lessons that a rate is just a comparison of two numbers or two quantities. For example, miles and hours. A unit rate is a comparison of two things as well, but the denominator is 1. So for example, instead of miles and hours, or miles per hours, we'll have miles per hour. So before we might have two numbers, two non-1 numbers, and then for our unit rate, the denominator must be 1. So I'll give you an example of an appropriate answer for this. And remember, quantities just means two numbers or values. So an example of an answer might be, rate is the comparison of two quantities. A unit rate is a rate. The denominator is 1. That is a comparison of a number of things per or to one single thing. So this is an example, my example for answer to number 1. Now we move on to number 2. Number 2 says, Sam has 9 friends over for his birthday party. If his mom bought a bag with 45 pieces of candy, how many pieces of candy will each friend have? So we've got a bag with 45 candies and we want to share it with 9 of our friends. So we're going to be converting a rate into a unit rate. So first we're going to need to set up our unit rate with the given information. So we know there's 45 candies for 9 of your friends. So the reason we decided to put 45 in the numerator is that you'll notice in the question it says that they want to know how many pieces of candy will each friend have. So notice that pieces is plural. It's talking about many pieces. So that means it's not going to be single. It's not going to be 1. Also notice that friend or friends is in the question changed to friend. Therefore, friend is changing to 1, so friend will be the denominator, leaving candies as the numerator. So our goal is some number of candies, we'll call it y, per, or divided by, 1 friend. In other words, how many candies or y candies for each friend. So the way we're going to do this is we're going to have to divide both the top and the bottom by the denominator. So we'll divide 9 by 9 and 45 by 9 in order to figure out how many candies per friend. Oh, let me set this up correctly. So in the denominator, we've got 9 divided by 9, which will give us 1. And I'll highlight that green so we remember that it has to do with the number of friends. 45 divided by 9. And remember, the reason we're dividing by 9 is that whatever we divide by in the denominator, we must also divide by in the numerator. So 45 divided by 9 is 5, and we'll go ahead and mark that as yellow so we remember that it has to do with the number of candies. So 45 divided by 9 is 5, and this tells us in context that we will have 5 candies per 1 friend. This can also be written as 5 candies for each friend. Essentially what we're saying is that each of our friends that we've invited can have 5 candies. So let's move on to the next one. Oh, don't want to show the 4th question. Don't want anybody jumping ahead. So number 3 says McDonald's is thinking about charging $6.90 for 30 minutes of Wi-Fi. How much would McDonald's charge their customers per minute of Wi-Fi? So again, this is offering us a rate, the rate at which people will pay for 30 minutes of Wi-Fi, and we are to turn this rate into a unit rate to determine how much people will be paying for each minute of Wi-Fi. So let's look at the information McDonald's gave us, or the question gave us about McDonald's. It says that 30 minutes of Wi-Fi is going to be $6.90. Well, when we set up our rate, we have to keep in mind that we're changing to dollars per minute. So minute is going to need to be in the denominator because that's what's being changed to 1. So we'll set up our rate as dollars over minutes, and remember that we're going to be changing it into minute, dollars over minute. So we know that we've got 30 minutes for $6.90. And remember, the goal is to change the denominator to 1, so it's a unit rate. And we don't know what the y value here is going to be because that's what we're trying to figure out. We're trying to figure out how much it will cost us for a single minute. So I'll go ahead and highlight these different colors. Now, in order to change 30 to 1, we must do 30 divided by 30, which will give us 1. And we'll highlight that green because that's our minutes. And Remember that if we divide the denominator by 30, we must also divide the numerator by 30. So then we'll have 6.90 divided by 30. I'm not sure what that is off the top of my head, so let's go ahead and do the math. 30 doesn't go into 6, so we write a 0. 30 does go into 69 twice. 30 times 2 is 60. We subtract those and we drop the 9, and then we bring down the 0. 30 goes into 93 times, and our answer is 0.23, or 23 cents. So in context, so that's our dollar amount, that's why we highlighted it in yellow. So in context, what we've essentially figured out is that it's going to cost us $0.23 or 23 cents for each minute of Wi-Fi at McDonald's. Alright, let's move on to number 4. So number 4 says Target and Safeway both have a sale for hot wings. Target is selling 2 bags for $7.49, while Safeway is selling 3 bags for $9.50. Who has the better deal? So remember that this is a comparing unit rates problem. But as we have it, we've got 2 rates, and those are not quite as easy to compare. But if we convert both rates into unit rates, we should be able to easily compare Target and Safeway and find out which one has the better deal. So on the left here, I'll go ahead and do the math for Target. Sorry, my handwriting's sloppy, but that says Target. And I'll do Target's math in red. So Target's charging $7.49 per 2 bags. And here on the right, I'll do the math for Safeway. And if I look again, Safeway is selling us $9.50 for 3 bags. That's the Safeway deal. So I can't compare these 2 rates because they're not very easy to compare, but I can divide both of them in order to find the unit rate. Remember, our y value, the numerator, divided by the x value, the denominator, will give us our unit rate. Give me 1 second. I'm getting a text message. Just want to make sure everything's okay. Yep, everything's fine. Sorry about that. Anyway, so we'll go ahead and do the math here. 2 goes into 7 3 times, which is 6. Subtract is we're left with a 1. We bring down a 4. 2 goes into 14 7 times. 14 minus 14 is 0. We bring down the 9. 2 goes into 9 4 times, which is 8. And we subtract 8 from 9, and we're left with 1. And we bring down a 0, and we know that 2 times 5 is 10. So our answer is 3.745. So now we know that Target's unit rate for their deal is $3.74 and a half cents, or $3.745. Now let's go over to Safeway and convert their rate into a unit rate. So we'll take $9.50 and divide it by 3. So remember, when we have a fraction, the numerator will go inside the division bar and the 3 will go on the outside. So 3 goes into 9 3 times. 3 times 3 is 9. Subtract is equal to 0. We bring down the 5. 3 goes into 5 one time. If we subtract, we have 2. Bring down the 0. 3 goes into 26 times. 6 times 3 is 18, and we're left with 2 again. And as you'll notice, we'll bring down another 0, and 3 goes into 26 more times, and we'll be left with 2 again. And so this will continue to repeat. So our answer will have a repeating 6 in the decimal. So our unit rate for Safeway will be $3.166 per bag. So since we have these in unit rates, we can now compare them. So Target's going to charge us $3.745 per bag, or $3.75, while Safeway is only going to charge us $3.17 per bag if we round up. So we have to compare. The better deal means the one that's going to be cheaper. $3.17 is cheaper than $3.75. Therefore, we know that Safeway is actually the better deal. Okay, the next page of our study guide talks about unit rates in table graphs. Or in tables and or graphs, sorry. So the first question says, what makes a graph proportional? Use math terms, and then create an example of a proportional graph. So let me erase the answer to the one of the first problems we had. Anyway, remember we had a PowerPoint talking about the rules for things being proportional. And it said for a graph it must have two things. First, it must be a straight line. The points must create a straight line. Additionally, it must pass through the origin. So we'll draw an example of one real quick. So in order to be proportional, we must have a straight line and it must pass through the origin. So as you can see, our straight line goes right through the origin. That makes this proportional. Now we can draw a couple of other examples of graphs that are not proportional so that you don't accidentally draw these on your exam. So while this line is straight, it does not go through the origin, therefore it is not proportional. Oh, I'll get rid of one of those lines so it doesn't look as confusing. So this is not proportional. Another example of a graph that is almost proportional. So this one does go through the origin, but notice it curves as it increases. This is also not proportional because while it does go through the origin, it is not a straight line. So our bottom two examples are examples of graphs that are not proportional. So our answer to the first one, a graph that is proportional, the top one would be an example of that. So now, what would we write as a definition for what makes a graph proportional? Oh, whoops, I think I closed my notes page. Sorry about that. So I might say something like this. And if you'll recall, you can find this information on one of the previous PowerPoints. A graph is proportional if its points make a straight line and if it passes through the origin. That's pretty much it. This would be a satisfactory answer for that question. Okay, so for number 2, it says, would these points represent a proportional relationship, and how do you know? So there's a couple of ways we can go about solving this, and the first way we'll do it is by using the graph since they've presented us with one. I'll go ahead and make my graph with all 4 quadrants, but the graph to the right there is also okay. And I'll go ahead and we'll make my points in different colors just so it's easy to see where each coordinate is placed on the graph. We'll just draw 5 little marks on both the y and x axes. So our first point is going to be at 1, 1, which is about right here. The next point, our orange point, is at 3, 4, which is about right here. So far this could be a straight line, although at this point it may not pass through the origin. The green point, our next point, is going to be at 4, 4. And our final point, the blue point, is at 5, 5. So you'll notice that we don't really have a straight line here. If you'll notice, one of our points doesn't seem to be in line with the others. The orange point seems to be kind of off. So the other 3 points seem to form a straight line that does go through the origin. But the problem is the orange line doesn't fit on that line. The orange dot doesn't fit on that line, the orange point. So while all of our points fit, the orange one does not, and that means that this cannot be proportional. So now we'll go about a different way of verifying the proportionality of this set of data, this graph. So we verified it visually using a graph, but remember that we can find the unit rates for each of our points and determine whether or not they are proportional. Recall that our points are set up as the coordinates x and y, and that in order to find a unit rate, we must have y divided by x. So again, I'll color coordinate my answers, my unit rate answers, and we're just going to take the y value of each coordinate and divide it by its x value. So 1 divided by 1 is 1, so our unit rate for the first point is 1. The unit rate for the second point, well, we'll skip that one for a second. We'll leave it up there, but that was the one that caused us problems before, so we'll just do that one last. 4 is the y value of our second point, and our third point, and 4 is also the x value. 4 divided by 4 is 1, and 5 divided by 5 is also 1. So each of our points have a unit rate of 1, but now we'll check that orange value that was giving us trouble on the graph. 4 divided by 3, so if it's 4 divided by 3, the numerator goes inside the division bar and the 3 goes on the outside. 3 goes into 4 one time, and then we'll add a decimal and bring down a 0, and we're going to get a repeating decimal of 3. So our answer is 1.33 repeated. So you'll notice that for each of our points, aside from the orange one, our unit rate is 1. Unfortunately, the unit rate for our orange point is 1.33 repeated. That would mean that this is not proportional. So we've gone ahead and verified this 2 ways. Let's go ahead and move on to number 3 now. Number 3 says, what makes a table proportional? Use math terms. Create an example of a proportional table. So remember that a table has x's and y values, and they can either be set up horizontally in a table or vertically in a t-chart or table. So we're going to need to set up our own proportional table. And remember, that means for a table to be proportional, it must have the same unit rate across the board. That means for each coordinate that we have, or each pair of numbers for y's and x's, must have a constant rate of change or a constant of proportionality that's the same. So this might look something like this as an answer for this question. A table is proportional if it has a constant rate of change. And that's pretty much a satisfactory answer. As long as the table has a constant rate of change, it is in fact proportional. So this might look like, as the second part of this question asks us to create an example of a proportional table, we'll go ahead and set up our y's and x's. We'll extend our table out, and we're just going to do it horizontally. I went ahead and erased the 0 here, but I in fact could have put 0, 0 as my point, because in order to be proportional it must pass through the origin. But we'll do 1 and 2, just because 1 times 2 is 2. For a unit rate of 2, 2 times 2 is 4, and 3 times 2 is 6. So again, we can confirm to make sure that our points have a unit rate of change by dividing them. So our y's divided by our x's. 2 divided by 1 is 1. Oh, I'll write this as a fraction instead. 2 divided by 1 is 2. I'm very sorry. I think I said 1. 4 divided by 2 is also 2. And 6 divided by 3 is also 2. So you'll note that our unit rate for each one of these, or our constant rate of change, is 2. So that was a proportional table. Now, the next topic is equations. Number 1 says the unit rate between two measures is 3. What is the equation? Well, remember that a unit rate means that as the x increases by 1, so 1, 2, 3, 4, the y value will increase by the unit rate, or 3. So it'll go up 3, 6, 9, 12, 15. It will continuously go up by 3 every time x goes up by 1. So that means we can plug in any number for x, and if we multiply that number by 3, we will get our y value. So we can plug in any number for x. It could be 4, or 3, or 5,000 if you wanted to. And if we multiplied that number by 3, we would end up with a y value, because we know the unit rate. So y equals 3x is our equation. So now let's get rid of this. Number 2 says write an equation based off the proportional table from y to x. So again, remember, if we have a table, in order to set up an equation, we must have a unit rate. Now, this doesn't have the unit rate currently present, but we can use the data provided to find the unit rate in order to establish an equation. Oop, having trouble drawing my last line here. That's not going to give me enough space. So let me just move it over. There we go. Okay. So our first set of data is 4 in the y value, and the x value is 2. For our second, the y is 10, the x is 5. For our third, the y is, y, we don't know what it is, and the x is 14. And for the fourth point, the y is 30, and the x value is unknown, so we'll leave it as x. Okay, so the two pieces of data that have the y and the x value, we can't really use those to establish the unit rate because we don't know what those values are. But we can divide the 4 and the 2 and the 10 and the 5 in order to find out what our constant rate of change is. 4 divided by 2 is 2. 10 divided by 10 divided by 5 is 2. So we know that our constant rate of change is 2, and we need this in order to set up our equation. It means that any number we substituted in for x, if we multiplied by 2, we would get our y value. So our equation must be as follows. Our y value is equal 2 times any number we plug in for x. Now we can verify this. So if we plugged in 2 for x and multiplied it by 2, we would get 4, which is our corresponding y value. If we plugged in 5 for x, we would get 10, which is our corresponding y value. I'll go ahead and show this, matching the colors. So if we plugged in 2 for the x value and multiplied it by 2, we would have y equals 4. Oh, I think I should make that red since it matches the point. There we go. Now, alternatively, if we plugged in y, or 5 as our x value, and followed our equation, so we multiplied it by 2, we would get y is equal to 10, which, as you'll notice, is the corresponding y value in our table. So we've successfully proven that our equation is correct. So our equation for this set of data is y equals 2x. Number 3 says use the equation, or use an equation that we've already found, to find the y value based off of the table. So we've got our table and we have a missing y value. We already know the equation, and for this point we don't know y, but we do know x. As you can see, x is 14, and so we can use our equation because, as we said before, any number we plug in for x, we can multiply it by 2 to get y. So if we go ahead and put 14 in for x, we should get the corresponding y value. 14 times 2 is 28. So y equals 28, which is the corresponding y value to the x value of 14. That means for that y value, we can go ahead and erase it and replace it with 28. Okay. Number 4 says use an equation to find the x value based off the table. So again, notice for this one we've got 30 as our y value and x as our x value. So this one's kind of interesting. We don't know the x value, but we do know the y value. So we don't know what we can plug in for x, but we do know that we can plug in a 30 somewhere. Well, we know that y is equal to 30, so we can take y and replace it with 30. And that'll look something like this. 30 equals 2 times our mysterious x value. So, in order to isolate x, in order to find out what an x is equal to, we must undo that multiply by 2. And in order to undo it, we must do the inverse operation, which is division. So we must divide both sides by 2. Remember that this is an equation, so what we do to one side, we must do to the other. 2 divided by 2 becomes 1, and we can write that as 1x or just x. And 30 divided by 2 is 15. And that's our answer. So again, we can go back to our table and we can plug in a 15, and this says if our x value is 15, then our y value will be 30. Alright, we finished number 4. Number 5 is a 4-part question. It's got an A, a B, a C, and a D. So we'll start with A. Number 5, in general, says solve for the given variables. Use any method. So you recall in class I taught you 3 different methods to solve this problem, or these problems. I prefer the butterfly method. It's faster and requires less work, so I'm going to depend on that to do these. So for 5A, we'll go ahead and set up our ratio or our rates. And I'll just be following the list of steps that I gave to you guys in last class. So first I'll circle my butterfly wings, and I'll go ahead and use 2 different colors. And now I will set up my equation or my corresponding factors. So I'll take the first butterfly wing and multiply it together, so 20 times 3. And I'll set it equal to the product of the second butterfly wing, which is 12 times x. Again, just remember that the way we do it is after we make our butterfly wings, we set one butterfly wing, or the product of one butterfly wing, equal to the product of the second butterfly wing. 20 times 3 is 60. And let me change my color. (12 times x is 12x). So now we found out the value of 12x's, but I need to know what 1x is so I can figure out what my missing value is in the rates. So in order to do that, I'm going to need to divide both sides by 12. On the right side, I end up with 12 divided by 12, which is 1, which means that it'll come out to x or 1x. I'll just leave it as x. 60 divided by 12 is 5. So x equals 5. Oops, let me write that in a different color. X equals 5. So that's the answer to A. Now let's do 5B. So I'll go ahead and write my ratios. And then I will set up my butterfly wings. I will set the product of one butterfly wing equal to the product of the second butterfly wing. And remember that product means multiplication. So the product of the first butterfly wing is 7 times 7. And I will set that equal to the product of the second butterfly wing, which is 49 times y. 49 times y is just 49y. And we will set that equal to the product of the first butterfly wing, or 7 times 7, which is also 49. Now in order to isolate y, we will divide both sides by 49. On the right, 49 divided by 49 will leave us with 1, so we'll have 1 or 1y or y. I'll just write it as y. And on the left, 49 divided by 49 is also 1, so we'll end up with y equals 1. Alright, now we'll tackle C. I'll set up my rates once again, and then draw my butterfly wings. Now I'll set the product of the first butterfly wing, or x times 48, equal to the product of the second butterfly wing, or 4 times 12. I'll go ahead and multiply these out. 4 times 12 is 48, and that will be equal to the product of the first butterfly wing, which will be x times 48, or 48x. Again, at this point we'll have to isolate x, and in order to do that we'll have to divide both sides by 48. On the left side we'll have a common factor in the numerator and the denominator, so the 48 divided by 48 will become 1. On the right side, 48 divided by 48 is also 1, therefore x equals 1. Now for D. Again, we'll set up the ratios it's given us, and we'll draw our butterfly wings. We will set the product of the first butterfly wing, or 16 times 1, equal to the product of the second butterfly wing, or 4 times y. Oop, that's not a plus, that should be multiplication. So, on the right side, the product of 4 and y is 4y, and on the left, the product of 16 and 1 is 16. Now, in order to isolate y, we'll divide each side by 4, because remember, we're trying to get y by itself. And we'll set both sides, we'll divide both sides by 4, since it's an equation. 4y divided by 4 is just y, and 16 divided by 4 is 4. So y equals 4. And we're done with that. The next part of our review is unit rates and graphs. I believe this is the last portion of our review. So the first question is, what is the unit rate here? Well, you'll notice that we don't really have a value on the line for 1, because our x-axis is labeled as 2, 4, 6, 8, and not 1, 2, 3, 4, or something like that. So let's go ahead and set up each of these points as a table, just so they're a little bit easier to see, so we don't have to go back to the line and look each time. So the first point it gives us is 2 in the x, and in the y it is 94. And then the next point is 4 in the x and 188 in the y. The third point is, looks like 282 in the y and 6 in the x. The fourth point is 376 in the y. And let me move that over so I've got room. The fourth point is 376 in the y and 8 in the x. And the final point that we have here on our line is a value of 470 in the y, corresponding to a value of 10 in the x. So it says, what is the unit rate? Well, remember that unit rate must be y divided by x. So we can go ahead and take one of our points and divide it to find the unit rate. We're not going to need to confirm a constant rate of change or a constant unit rate, because we can see that our line is straight on the graph and it passes through the origin. So we'll do 94 divided by 2. 2 goes into 9 4 times. We'll subtract, and then we'll be left with 14. 2 goes into 14 7 times. So our so 94 divided by 2 is 47. So let's take this 47 and set it up as a unit rate. There we go, 47 over 1. So that's our unit rate. But we're not quite finished answering. We need to know what this means in context. 47 what over 1 what? Well, notice that we have y over x, so let's look at our y-axis first. The y-axis says how much is saved, or in dollars. The x-axis says the number of weeks. So we've got $47 per 1 week as our unit rate. So number 2 says, what is the daily rate? Well, we found the weekly rate. We found what we earn in 1 week, or what we save in 1 week. We don't know what the daily rate is. We don't have a graph for that, but we do know that 1 week is the equivalent to 7 days. So we can just exchange that 1 week for 7 days. So we'll change it from $47 in 1 week to $47 in 7 days. And since it wants to know the daily rate, it's asking us for the unit rate in days. So once again, we're going to have to take a rate and turn it into a unit rate. We know that it's asking for the unit rate of 1 day, and we don't know what we're going to earn each day, so that's going to be our unknown, or our y value. Let me get rid of this real quick. Oh, I don't think I can actually remove it. I'll just erase it. Let me just move. I want to cut that off. Let me just move this up. And remember that our answer is going to be in dollars per day. So in order to change it to 1 day from 7, we'll do 7 divided by 7. But remember that what we do to the denominator, we must also do to the numerator. So we'll divide the numerator by 7. 7 divided by 7 is 1 day, and 47 divided by 7, let's see, well, we know that 7 will go into 47 6 times, and that will give us 42, and we'll be left with 5. And we're not out of room here. We'll add a decimal point and add a 0. 7 goes into 57 times, and that's 49. Let me erase this. Oh, wait, that won't work. So we had 50 here, and 7 times 7 is 49. So we'll be left with 1. We'll drop down another 0. And we'll have a 10. 7 goes into 10 once. And this will continue for a little while. But because we're talking about dollars, we can just go ahead and leave it at 2 decimals here. Remember that when we're talking about money, only the first two decimal points are relevant. Really, we should find the third in order to determine whether we're rounding up or down, but this is fine for now. So our daily rate is $6.71 per day. Alright, number 3 says, use the graph to the right, and A says, how many weeks does it take to save $376? So you'll notice in our table, well, let me get rid of all this first. It says to use the graph, and we can use the graph, but since we've already taken all the points from the graph and placed them in our table, we can use our table just as easily here. So notice that we've got a Y value of $376 corresponding to an X value of 8 weeks. So that means it's going to take us 8 weeks to save $376. So our answer for A, or for 3A, is 8. 3B says how much money will be saved in 12 weeks. Use an equation. Well, remember, an equation requires a unit rate. But remember, we found the unit rate for this already. We divided 94 by 2, and we got a unit rate of 47. So remember that when making an equation, we can take our unit rate, multiply it by our x value, and that will be our y value. So our equation should be 47x equals y. Now, B asks how much money will be saved in 12 weeks. Use an equation. So we have our equation, and we're trying to figure out how much we'll have in 12 weeks. Well, weeks is on the x-axis, which means it's our x value. So instead of x, we can write 12. We can multiply that 12 by 47, and that should equal our y value. So 47 times 12, I don't know that off the top of my head, so I'll go ahead and multiply that out. I'll carry the 1, skip place, 4 plus 0 is 4, 9 plus 7 is 16, 4 plus 1 is 5. So 47 times 12 is 564, which is our y value. Which in context means that y is equal to $564. So in 12 weeks, we will have earned $564. Or we will have saved $564 rather. Okay, let's get rid of. Oh, okay. Let's just read the next one. 4a says, what does the x and y stand for? Well, if you look at our graph, you can look at the labels on both the y-axis and the x-axis. Remember that the y-axis is vertical, and as you can see, it says total savings in dollars. So that's what our y means. Our x-axis is labeled as the number of weeks, and so that's our x value. So B says, how many weeks will it take to earn $705? Use an equation. Well, we've got an equation already, but this one's a little bit different. This doesn't tell us how many weeks. So, but it does tell us that we're going to have $705. And dollars is a y value because it's on the y-axis. So we can replace the y, the letter y, with the number 705. So essentially, 47 times some number, some x value, is going to equal $705. Now we must isolate the x to find out what it is, so we must divide each side by 47. Trying to do some mental math. I don't know what 705 divided by 47 is, so let's go ahead and we'll just write the math out. 47 doesn't go into 7, but it goes into 70 one time. If we subtract them, we are left with 33. Oh, no, it should be 23. And then we'll bring the 5 down. 47 goes into 235, I think, 5 times. And that should equal 235 exactly, which will give us a 0 and subtracted. So our answer is 15. So x equals 15. In context, this means that x equals 15 weeks. So essentially, it will take us 15 weeks to earn $705, or to save $705. So that's the end of your study guide. I hope that you enjoyed the video. If you've got any questions or comments, please feel free to email me, or you can contact me on YouTube and leave a comment, or you can come see me in person. And I'll go ahead and type up my email again here. Let me get rid of all of this. Oop, I just closed my note. Okay, here's my email. Again, my email is christopher.hickson@tusd1.org. So please email me and let me know if you've got any feedback. If you liked the video, you can tell me why, or if you didn't like the video, please tell me why as well. The feedback's very important to me. Alright, well that's it. Thank you guys very much, and I'll see you later. Bye.